Welcome to my video. Today our topic is the geometrical transformation, and we are going to solve a question from paper 1 of June 2010. The diagram below is on the next page shows three triangles P, Q and R. The diagram below shows three triangles P, Q and R. Triangle T is the image of triangle P under an enlargement with center 5, 2 and scale factor 2. P is object and T is image under an enlargement with scale factor 2 and center of enlargement 5, 2. Question is, draw and label triangle T on the diagram. It carries 2 marks. B part is describe fully the single transformation that maps triangle P onto Q, and C is find the matrix representation, the transformation that maps Q onto triangle R. This is diagram. Triangle T, P, Q and R are shown in the diagram. We have to draw T, which is image of P under an enlargement of scale factor 2 and center of enlargement 5, 2. X is the center of enlargement, which is 5, 2. I marked it here. We have to we should know the formula for the enlargement. Under enlargement we get the similar triangles. So for enlargement, if we have A and A dash, if A is the object and A dash is the image under the enlargement E, then if X is the center of enlargement, then A dash X over AX should be equal to enlargement factor K. Now, if the enlargement factor is positive, then the image and object will lie on the same side of the center of enlargement, and if the scale factor is negative, then otherwise. Now here the scale factor is 2. Scale factor is 2. So instead of K, we will write 2 here. So this will be equal to 2. Scale factor is 2. Now I will mark each perpendicular distance from X to each point of this, and then this double that distance to mark the image. Here, look here. This is X. This distance is from image. So this is this object. This is object. Its image under the enlargement scale factor 2 will be at distance double of this distance from X. This is 1, this is 2, so this is the image of this point. Similarly, image of this point will be, this is 2 boxes here, so image will be 4 boxes from here, because since scale factor is positive, so it is on the same side. 1, 2, 3, 4, so it will be here. This is the image of this point. Similarly, this is the image of this image. Image of this point will be 2. There is 2 boxes, then there will be 4 boxes. 1, 2, 3, 4. This. I join these points. So join these points like that by scale. So this is the image of P. This triangle T is image of P under enlargement center 5, 2 and scale factor 2. That's it. We have to draw fully the single transformation that maps triangle P onto Q. Okay. And this is Q. Q is the image of P under some transformation. Now look here, it is quite easy. If we rotate this object 90 degree through clockwise, anti-clockwise, then this line will be this line will be here. This is here. So it is 90 degree clockwise. Now how to find the center of that rotation? Okay, where is that center of that rotation? How to find the center of rotation? Join object and image corresponding points and draw their perpendicular bisectors. The points where the perpendicular bisector meet each other will be the center of rotation. I repeat, if we have an object and an image and we have to find the center of rotation, just draw the perpendicular bisectors of the line joining different points of corresponding points of object, image and the image. The point where the perpendicular bisectors meet each other will be the center of rotation. I draw for you and I will show you. Look here, I draw for you. This point is the image of this point. Okay, this point is object and its image is this. I join these 2 points and their perpendicular bisector is this line. Similarly, object is if this point, then its image is this point. So I join this point to this object image, then its perpendicular bisector is y-axis. Both these perpendicular bisector meet at origin. So it means O is origin is the center of the transformation, or I will know that the transformation is rotation. So I join this and object to image, this angle between them is this 90 degree anti-clockwise. So the transformation that maps P onto Q is the 90 degree anti-clockwise rotation about origin. So answer of B part will be 90 degree anti-clockwise rotation about origin. So the transformation that maps P onto Q is 90 degree anti-clockwise rotation about origin. It completes our solution of B part. C part is we have to find the matrix representation which maps Q onto R. We don't know whatever is. So how to find the matrix of a geometrical transformation? I give you detailed. Now if we have image and object under some transformation and we have to find the matrix representation, then how to find it? The process is, I suppose that transformation matrix is A, B, C, D. If I have a point P, whose points are x1, y1, and its image is P dash, which is x1 dash comma y1 dash, then how to represent this by matrix? Matrix representation will be matrix transformation matrix ABCD into the object points x1 y1 will be equal to, should be equal to x1 dash y1 dash. This is the process. we will have 4 equations and we can find these unknown. This is general process. We don't need to know what transformation is. It can be shear, it can be reflection, it can be any other transformation. Okay. Now here we suppose that our transformation matrix is A, B, C, D. Then here the points of the objects. This is object. Question is Q is the object and R is the image. So Q, this is the object. This point is reflected, is mapped here on this point. So original point is what? I write it. Its coordinates are -2, 4. So I write -2, 4. This is -4, 4. -4, 4. And its image is, what's the image? Its image is -2, -4. And its image is -4, -4. Now I solve it. 2 minus 2a, I multiply it. -2a plus 4b should be equal to this number. This is -2. This is equation number 1. Next is this minus, I multiply this with this. So this will be equal to -4a plus 4b. Again -4a plus 4b is equal to this number. This is equal to -4. These are two equations. We solve it to find the a. If we subtract them, this is plus, this is minus, this is plus, they are cancelled. Plus 4 minus 2a is 2a is equal to 4 minus 2 is 2. So we get a is equal to 1. If I put a here or here, then it will become, I put this here in this equation, then -2 into 1 plus 4b is equal to -2. So 4b is equal to -2 plus 2. This will become plus 2 here. So this implies 4b is equal to 0. B is equal to 0. So we get b is equal to 0. Now we find C and D. Look here. C is -2c. We multiply this first row with this first column. So minus 2c plus 4d. Then I -4c plus 4d, and this will be equal to -4, and this is also equal to -4. So I subtract it, plus, minus, and plus. Cancel there. 4c minus 2c is 2c. 4 cancel is equal to 0. So you get c is equal to 0. If we put c is equal to 0 in any of this equation I suppose, then this will become -2c, c is 0, plus 4d is equal to 0. So I get 0 plus 4d is equal to 0. So this is equal to -4, sorry. So 4d is equal to -4 and d is equal to -1. I found A, B, C, D. Therefore, the transformation matrix T is equal to what? A is what? A is 1, B is 0. So it will be equal to 1, 0, C is 0, -1. So this is the transformation matrix. We don't need to know what transformation is. The transformation matrix to represent a transformation that maps Q onto R is 1, 0, 0, -1. So if you know this, what is this transformation? This is reflection, basically reflection in the x-axis. So if we look closely on the diagram, the QR is the reflection of Q in x-axis. Therefore, our answer is correct. So that matrix that represent transformation that maps Q onto R is 1 0 0 minus 1. This is one way. This is general way. You can, if you do, you have to need only the image and the object. Then this is a formula. Matrix ABCD, object is equal to image. It will give you any transformation for matrix for any transformation. But there is some other methods which are specific to the transformation. For example, if we have to find know the transformation, it is reflection, then how to find this? If we suppose do 2 points, one point is 1 0 and second is 0 1, and we know that if we have to find the transformation matrix in the x-axis, no, 1 0 0 1, this is the object. Under some transformation, its image should be equal to what? Its image should be equal to in x-axis. If we reflect these points in x-axis, this is x-axis, this is y-axis. 1 0 is on x-axis, so it will remain unvariant. So its image will be 1 0. So this is it will stay as 1 0. 0 minus 0 1 is this point. If it is reflected in the x-axis, its image will be here, and this will be 0 comma minus 1. So this will come minus 1. So this will be the transformation matrix that represents reflection in the x-axis. 1 0 and 0 1, we take 2 points and takes their images. Then images will be gives you the transformation matrix of the original matrix. Okay, so this is one another way of doing it, but it is also derived from this method. This is the general method. So this is the way you do the transformation questions in the paper 1 question. Hopefully, so students, that was our topic for today's discussion. That is the how to solve paper 1 questions about geometrical transformations in the O-level exam. I hope you understand everything. If you have any query, you can ask me in the comments. I will give answer to all queries inshallah, and hopefully you like this. So please like it, share it and subscribe my channel, and also press the bell icon so that you can get the notification of all my videos. Take care. See you next video very soon. Until then, bye bye. Take care.